All right, students, so many of you wanted to see a Unit 3 review video, and this is going to take you through most of the topics that we studied in Unit 3. So here's a triangle, ABC, and most of these topics were related to triangles, so here we go. So the first topic we thought about were parallel lines and transversals. So here we have these two blue parallel lines. I should mark them as parallel. So that's what these arrows on the lines mean, that these lines are parallel. And then this is our transversal here. And then so what we learned were that all of the acute angles, so the ones that are less than 90, are congruent to each other. And all of the obtuse angles are congruent to each other for various reasons. So first off, we learned that vertical angles, so anytime you have intersecting lines at all, it doesn't even have to be parallel lines and transversals, but when we have, say, this one set of intersecting lines here, when they form an X, the angles opposite each other, so these two acute angles here are going to be congruent, and then these two obtuse angles are going to be congruent. So those were vertical angles. And so those are the congruent angles there. And then we also learned, as I mentioned, that all of the acute angles, so all of these ones marked as yellow, are congruent to each other, and all of the orange obtuse angles are congruent to each other as well. We then learned that an acute and obtuse angle, since they form a straight line, they're going to be 180 degrees, so they're supplementary. So we can take any set of acute and obtuse angles, say this acute angle here and this obtuse angle down here, and we're going to know they're going to be supplementary angles. So we can add those together and set them equal to 180. And those are going to be the two types of problems that you're going to see. You're going to see they'll probably give you one acute angle and one obtuse angle, and you're going to have to figure out whether they're supplementary or congruent. So sometimes this will be in algebraic expressions, like this will be, say, x plus 2, and this will be x minus 15, and you're going to have to add them up and set them equal to 180. Or sometimes they'll give you an acute angle and an acute angle, and you'll have to figure that out. So let's take a look at an example. So here's an example where they've given us two acute angles, and this is a pair of vertical angles, so we're going to set them equal to each other. Again, if they gave us an acute and an obtuse angle, they would equal 180. So you would add them together and set them equal to 180 degrees. So these two angles would be supplementary, or any acute angle and any obtuse angle would be supplementary. So this is how we would solve this. Don't forget to use SADMEP. So if it's an algebraic equation, we're going to do reverse order of operations. So the first thing I'm going to do is subtract the 3x from both sides. The next thing I'm going to do, and this is going to leave me with x minus 7 equals 9, is I'm going to add the 7 to both sides. And that's going to leave me x equals 16. Now, sometimes they'll ask you for x, and you're going to have to solve for x. Sometimes they're going to ask you for the angle measures. So you just have to plug x, whatever you found for x, back into the angle measures. And then I can find that this angle here is 57 degrees. Once I know one angle measure, I know all 8 of these angle measures, because I know all of the acute angles are going to be congruent, and the obtuse angles will be supplementary to that acute angle. So that's one example. So then we used the fact about parallel lines cut by a transversal to prove that the angles of a triangle sum to 180 degrees. So we know if you actually flip this whole thing upside down, you can see that these three angles here form a straight line, so they need to add up to 180 degrees. And then what we can also determine is that we have two sets of alternate interior angles. So since we have two transversals here, we have this one here on this blue side, and then this one here on the red side. Now, the two acute angles on this transversal are going to be congruent to each other, and then the two red angles on this side will be congruent to each other. They don't necessarily they're not all congruent to each other, like this red angle is not congruent to this one necessarily, but so any acute angle along the transversal that intersects the parallel lines, they are going to be congruent. And this was known as alternate interior angles. So they're on the alternate sides of the transversal inside the parallel lines, and same with these two here. So if we know they're congruent to each other, then these three angles form a straight line. They must be 180 degrees. then this blue angle down here and this red angle down here and the same yellow angle must also equal 180 degrees. So that's our angle sum theorem. The angles of a triangle have to add up to 180 degrees. And this is a fairly common proof that you'll see. The next thing we did is we actually used the angle sum theorem to prove that the exterior angle equals the two remote interior angles, remote meaning not connected to. So I extended this side of the triangle out, and you can extend any triangle side out. Like we could extend this one out here and have an exterior angle on this side, or we could extend this one down and have an exterior angle down here. There are many different exterior angles. Actually, there's 6. So let's look. Here's our exterior angle, the one on the outside. We know it's going to equal these two, and that's what we proved. So the angle sum theorem of a triangle, the exterior angle theorem of a triangle, is just an extension of the angle sum theorem. Get it? Extension. Huh. Oh, anyway. All right. So here's our our exterior angle theorem. The measure of angle A plus the measure of angle B equals this measure of angle X on the outside. And how does this connect to our angle sum theorem? Well, here's our angle sum theorem. A plus B plus C equals 180 degrees, these 3 angles on the inside. And we also know that this angle X and this angle C form a straight line. They are supplementary angles. They're a linear pair of angles. They also equal 180 degrees. So using the transitive property, we can say that these two things are equal to each other. So that's what I did. I set them all equal to each other. M measure of angle X plus the measure of angle C, these two, have to equal these 3 because they equal 180 degrees. Then, using simple algebra, if I subtract measure of angle C from both sides, these just cancel out. They just disappear. So what's left is this, our exterior angle theorem. The measure of angle X equals these 2 remote interior angles. Now, if you forget this theorem, you can always back into it using the angle sum theorem. It's just a nice theorem because it's kind of a shortcut. Allows us to solve some problems a little faster. The next thing we looked at was the inequality theorem. And remember, we took a bunch of straws in class and we tried to piece triangles together with the straws. So I have some look like straws here. So I have this yellow one and a red one and a blue one. And so what we learned is certain lengths could not form triangles. And that was our inequality theorem, that the 2 shorter sides must be greater than third and not greater than or equal to. They always have to be actually larger than the third. And let's look at some examples. So for example, I think we used in class the side lengths of 1, 3, and 5. 1 plus 3 is 4. That is not greater than 5, so they won't be able to you can't actually create an angle and connect them. They won't be long enough. So here's another example. This would be an isosceles triangle, 3, 3, and 6. 3 plus 3 is 6. So that's not a triangle, right? 3 plus 3 is not greater than 6, so that doesn't work. So that's not a triangle. What about 3, 5, and 5? Well, 3 plus 5 is 8. That is greater than 5, so that isosceles triangle would work. How about this scalene triangle here? If we had and we looked at 1, 3, and 5, if we had, say, 1, 4, and 6, 1 plus 4 is 5. That is not greater than 6. That doesn't work either. How about this scalene triangle? 2, 6, and 7. 2 plus 6 is 8. 8 is greater than 7. That could be a triangle. So, again, the inequality theorem, the 2 shorter sides have to be greater than the third. And that's the easiest way to figure them out. The next side theorem we looked at, which is one that we're going to use a lot in class, is our Pythagorean theorem. So let's take a look. So if we have a right triangle, and I'm going to label these sides A, B, and C, and we actually cut out some right triangles in class and some squares and showed that the area of the square A and the area of the square B, if you add them together, they would equal the area of the square formed by side length C. And that's what this equation is here, the Pythagorean theorem. A squared the length of this side squared plus the length of this side squared equals the length of this side squared. So let's look at an example. 3, 4, and 5 is a famous Pythagorean triple. There are just 3 integers that we know that satisfy the Pythagorean theorem. So 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 equals 25. So that works. And this, we could use any multiple of 3, 4, and 5, and that would also form a right triangle. So you could do like 6, 8, 10, 9, 12, 15. You could do what's 3 times 5? 15. 4 times 5 is 20. 5 times 5 is 25. So you could do 15, 20, 25. That would work. Let's take a look at an example, because generally they will give you 2 of the sides, and you'll have to figure out the third. So let's say this is 5. That's not an S, that's a 5. 13 and X. So I get asked this question a lot. They always ask, Mr. Fitz, which one's C? Well, C is always going to be the side opposite the right angle. So if I'm standing here at this right angle, looking across is the hypotenuse. So that is the longest side, the hypotenuse, and then this side here would be a leg, and this side would be a leg. Now, it doesn't matter which I use for A and B, because notice I'm just adding them together, and I can add in any order. Adding is commutative. So I can set this equal to A and this equal to B. I generally try and make the shorter side A and the next one B, just to be consistent. But again, it doesn't really matter. So it would be 5 squared plus X squared equals 13 squared, because X in this case would be my B. So 5 squared is 25, X squared is X squared, and 13 squared is 169. So if I subtract 25 from both sides, I get X squared equals 144. I take the square root of both sides, and I get X equals 12. So the length of this side is 12. We're going to be using Pythagorean theorem a lot this year, so if you have any questions about it, please come see me in class. And I hope this helps, and send me an email, or if you have any questions, let me know. I'll be in lunch and office hours for any extra help. Thanks for watching.